Good day. My name is Dave Cowles. I'm the Marketing Development Manager of Nanotechnologies with Valmet Incorporated, and today I'm going to discuss microfibrillated cellulose, or MFC, in tissue, both the creation and application. First, we have to ask, how do we at Valmet define MFC? It's still evolving every day, but right now, for the sake of this presentation, we basically express the amount of refining done as a percentage of fines, usually somewhere between 70 and 100% fines. You may ask, what is a fine? A fine is a fiber that is less than 0.2 millimeters in length. And we typically use a measurement device such as the FS5 shown in the bottom right as a way to analyze the fiber. There are also other ways that can be done with other competing devices. The picture in the top right, is MFC. In layman's terms, MFC is much like spaghetti. As you can see, it's longer, it's stringy. Even though we're talking about fines at less than 0.2 millimeters, it still is a long and heavily fibrillated fiber. Ours is a refiner-based process. In other words, we do not use additional chemistry. It is purely a mechanical standpoint. We can use either a DD refiner 6000, an Optifiner Pro, a conical refiner, and as you can see in the top right is a picture of a skid refiner, a DD skid refiner that we've used for mill trials that is available for rental. The bottom right is a picture of our Optifiner Pro 1. By the end of 2019, we had approximately 5 commercial facilities up and in production across the world. Most people ask how much power. This is an example of something, some fiber that we used. This was bleached eucalyptus. This was refined in our Karlstad, Sweden pilot facility for tissue using our skid refiner. There's 2 fines measurements here. As you can see, there is some difference. The top line is a measurement of total fines using our FS5. The bottom gray line is the same pulp analyzed using an FQA analyzer. As you can see, typically what we put into this fiber was approximately 650 kilowatt hours per ton net. Now let's talk a little bit about our tissue center in Karlstad. This just gives you kind of a nice summation of what we're able to do in the machine that is available in Karlstad for pilot trials. It's really a good way to, shall we say, experiment with some more out-of-the-box thinking compared to your normal tissue and towel, and it can be set up in 4 different configurations. As you can see, the basic anatomy of the machine you can see on the right hand as far as machine speed and sheet width and etc. This next slide shows the different configurations that it can be set up in, and it varies between these different configurations depending on customers and the time of year. Now let's get into some specific case studies. The first case I'm going to look in was actually something that was done in North America on a private label tissue machine and a commercial tissue machine. The material was produced, the MFC was produced at University of Maine, one of our alliance partners. The overall goal was to replace softwood in their bath tissue. We refined the fiber to about 90% fines using a 2-stage process at University of Maine, and the addition rate was 2.5% MFC internally added post-machine chest. Specific results are covered by an NDA, but the softwood was able to be removed on all the bath tissue that were run. There are a total of 3 bath tissue trials that were evaluated, and all of them basically were successful. The drainage remained basically unchanged and within the machine control limits because we were at 2.5% consistency. Obviously, if we had gone crazy and increased the dosage a great deal, we might have influenced drainage and things like that. Bulk and softness were also unchanged based upon their normal specifications. As I said, the results were confirmed 2 additional times. An additional 4th trial was done on some of their towel grades. Obviously that had a higher strength specification. We were able to, at the same 2.5%, we were able to remove some of the softwood, about 50% or so, and to still maintain specifications, but we could not really take out more softwood on that. Case study 2 was done on our pilot machine, and that we can share the data because it was a trial that we at Valmet ran. As you can see on the upper left-hand corner, there's a picture of 2 of our smiling employees, and that is our skid, or European skid refiner that we used to produce the material. The Karlstad machine was set up under the NTT configuration. Once again, our overall goal was to replace softwood using generic 20 gram per square meter bath tissue. Eucalyptus hardwood was produced in Karlstad using that skid refiner. We decided to go with a higher addition rate simply because this was the first trial that we ran at Karlstad, and we wanted to make sure that we saw an effect. And we used 2 different fines materials. I'll call them high fines and low fines as I discuss the data going forward. And once again, MFC was added post-machine chest. This first slide here shows making of the tissue using the high fines, or 87% fines MFC. The far left hand shows the control with 20% softwood. That is their normal generic bath tissue. Then we have 4% and 6% add-on. Those are both, the softwood was removed, and 4 and 6% MFC was added. As you can see, we actually increased strength in those 2 cases. The far right-hand set of columns is the sheet without any MFC and any softwood. As you can see, it's a pretty weak sheet. This next slide depicts 65% fines or low fines material, taking much less power. Once again, on the far left, we have the control. Then we have 4 and 6%. Both of those cases, we basically match the strength. If we were to do this trial again, I would probably use something along the lines of 2 and 4. I would not go as high as 6. The next one over, once again, is the control with no softwood. At the end of this trial, we decided to just try something kind of crazy. So we just refined a little bit of the hardwood sheet without the softwood, and as you can see, just a little bit of refining the hardwood bumped us up in tensile. And then the final one on the right, far right, we did a little bit of hardwood refining and added 2% MFC. As you can see, we really impacted tensile. Next one shows the TEA. Once again, at high fines, we have the control, 4, 6, and then without softwood or MFC. As you can see, we've got the strength climb once again by adding the MFC, and the sheet without any softwood or MFC was fairly weak. This is again low fines, looking at TEA. This I consider more of a success in regard that we were able to match strength, which ultimately was our goal at both 4 and 6%. As I said, I would have also run 2 in hindsight. As you can see in the control with no softwood, we did lose strength. Once again, with some additional refining, we really increased the TEA. In the next slide, you'll see the consequences. This is softness. Once again, we have, on this one, we have the high fines at 4%, low fines at 4%. As you can see, the high fines and low fines, even at the 4%, when we have the lower refined material, it certainly helps softness. Then the high fines at 6 and the low fines at 6. Once again, the lower fines or less refined material carries a higher softness with it, but not, and the dosage, as you can see, does matter between, let's say, comparing the high fines at both 4 and 6%. 4% has a higher sheet softness than the 6%. Same thing with the 4%. The control with no softwood, as you can see, is a very soft sheet, but as we can remember from some of the previous slides, it was not terribly strong. Then, as you can see, that our experiment that we did at the very end, we had the control with the extra refined hardwood, and then the refined hardwood and the MFC, in which we both lost softness. So, just refining and just adding MFC and all that, it will increase strength, but it is somewhat of a balancing act that you have to do with softness, and it is very obtainable, but it's just something that you have to keep in mind when running MFC. Conclusions. MFC is a commercially viable alternative for paper makers. It's not an R&D function anymore. We can produce commercial amounts of MFC using a variety of different pulps. Higher strength pulps, for example, softwood, can be replaced using hardwood MFC or something, or a lower quality fiber can be produced using MFC. We generally have tried to stay away from groundwood containing sheets or pulps. Total replacement of bath products and reduction of towel grades is possible. And tissue strength can be improved without chemistry for those of you that are using copious amounts of maybe CMC or GPAMs to enhance your strength. We believe that MFC is a sustainable and the original green solution for today's paper makers using a variety of different grades. Thank you for your time and attentiveness, and if you have any questions, feel free to contact me and I'll be happy to go over your specific needs and questions. Thank you and have a great day.
Hello everyone, my name is Marko Toskala and I'm coming from the Valmet Automation, Tampere, Finland. Next we will discuss about the interesting topic, how the quality management system takes a step towards an autonomous mill. If we think about the quite standard challenges in the paper manufacturing, there is always need to cut the cost, but without sacrificing the quality. One very basic solution to improve the quality, stabilize the process, is the QCS controls with veterinary analyzers and precise measurements to reduce amount of the broke and cut down the production cost. So the result will be improved and stable end product quality, better runnability in converting and increased satisfaction of the end customer. As I said, that this is quite standard way what we have done in Valmet quite a long time already, and with a very good result. But if we want to take again the step forward, there's lots of new applications and features what we can utilize. Before we can go to the new features, new applications, it's very important that we have the foundation in the mill. And I mean in quality management system wise. So that the pulp quality management, consistency measurements, wet end management, wet end analyzers, and quality management and laboratory is in the good shape. Meaning that we have the equipment available, but more important that we have enough accurate data, enough accurate equipment, and also reliable equipment to bring that data. Before that, it's quite challenge to get any reasonable results with the next step applications, for example the industrial internet application. Of course, all these devices are not necessarily needed, but base equipment are needed. Okay, last year we launched totally new Valmet IQ system, and we are talking about the intelligent quality from the fiber to finished product. So more than quality control system. Valmet IQ is the only quality management system on the market that covers the entire value chain in pulp, paper, board, tissue and converting. It's globally leading platform for the scanners, measurements, profilers, controls and machine vision. So what are the totally new features in the Valmet IQ? We are talking about the total quality management systems. Valmet IQ cheers up the competitiveness of an entire value chain from the pulp, paper, board and tissue making to final converted products. Valmet IQ extends traditional QCS by closing the control loops for the parameters which have been operated earlier manually. Combining of the QCS and Valmet Industrial Internet solution expands the quality management to the next level. As one example of what new features we have in the Valmet IQ is the compressive moisture management concept from the headbox to the reel. Meaning that we have the needed dryness and moisture measurements through the machine. From the wire section, measuring dryness in the press and after press, moisture measurements to measure the moisture after press and inside of the drying hood, through the machine at the end of the machine where we have the scanners to measure the moisture again and the end quality of the paper. So full concept to measure the moisture and see the development of the moisture and dryness through the machine. And not just measure, but we can also connect these new measurements to the optimizing control, so that this measurement will be the input for the controller and outputs are for example, the stock flow ratio, adjustable foils in the wire section, foam vacuums, pressed roll shakers, steam pressure inside of the dryer hood. So with this kind of optimization algorithm, we can optimize the dryness, but of course, because these wire section changes will affect also for the strength properties, formation, so on. So these are very important that this will be the input for the optimization control also. But with this way, we can automatize the whole wet end of the machine, and that way really build the online controls for this kind of controls we have been done earlier only manually by operators. Okay, what is the right way then and right roadmap to go towards the automatically controls and machines? Very important, as I told earlier, that we have enough data available and reliable data available. But the process starting from the data discovery, so that we collect the data from the machine, analyze the data to create the quality model for needed quality parameters. With the model, we can build online quality predictor to predict the quality parameter, like for example the strength properties or modeling or whatever, this kind of parameter what is normally measured only in the laboratory and not possible online. After we have reliable online quality predictor in the machine, we can start to optimize that online to find the right parameters to optimize these quality parameters, and that way we can build the automatic control and optimizer for these kind of parameters which have not been earlier possible. Okay, here is the good example how we can utilize the new tools and data discovery to build the online model and also the optimization for the parameters which have been measured earlier in the laboratory. So background, this is the white top liner machine and the annual production 400,000 tons per year. So background, white top modeling is one of the common quality issues on the white liner grades, and white top liner bleached fiber cost is of course high, and the and significant savings can be reached if we can optimize that layer. Target is to find the main parameters to affect the white-top modeling, utilizing the data discovery, and build the white-top modeling online model optimization on top of that. Also improve the overall cost efficiency with the new tools. And here we are utilize the data discovery to find the right parameters to build the model, and then also after the model was ready, we utilized the Valmet online quality predictor, which online predict the quality in this time the modeling online, and then start to build the optimization top of that and controlling the machine so that the modeling issue will stay away, but we can save the white top layer fibers as much as possible. Also, there was include for the measurements like white water control measurements and systems, but also the Valmet IQ topography measurement to measure the surface quality. And what were the benefits for the customer? Significant savings on white top liner bleached fiber consumption and cost. Improved overall cost efficiency through the center lining, and we utilize also the Valmet Dynamic Center Lining Advisor, and improved quality of the production through the online monitoring of the change. And total annual savings 2 to 2.5 million euros per year. So very significant savings through this kind of optimization package. In the beginning of the presentation, I was telling that we launched a new system, Valmet IQ, and we are talking about total quality management from fiber to converted to end product. And the idea there is that we are linking the data from the board or paper machine to the converting phase. So we are collecting all data from the DCS system, QC system, massive vision system, stock prep and wet end analyzers and measurements and laboratorium measurements to the customer roles. So all quality data what will be collected from the paper machine are saved for the customer roles. And when the roles is going to the converting machine, this data is read to the converting machine. So depending which process we are talking about and which kind of grades we are talking about, also the mills can be integrated or non-integrated, but anyhow the main idea is so that the data saved for the customer roles are transferred for the converting lines, corrugators or laminators or PE coating or whatever is the next phase in the converting for this paper or board. When the customer role is coming to the converting line, the all quality data what is saved for the customer role will be read for the converting line machine and utilized for the machine parameters and quality control parameters in the converting line to reach the targeted quality level in the converting. Valmet have very wide offering also QCS systems for the converting lines like corrugators, laminators, PE coating and so on. So the quality what have been reached in the converting is then also saved and sent back to the paper and board machine to utilize that data in the runnability of paper machine with the optimal way so that raw materials energy can be saved and the quality will be in the good enough level to make the targeted quality level in the end of the converting. So that way that way both the converting line but also the paper and board line can be optimized with the best way. Thank you. That was my presentation this time, and I hope that was interesting for you. So thank you.
Good afternoon.
Good afternoon.
Hi. Good afternoon.
No.
Okay. I'm welcome to these question sessions. We got a few for you. We have with us Marko, Toskala, and David Cowles that were our our key speakers, and we will be here to answer to the questions that our colleagues will present to you. I will have for David. I would like to ask him one question. Is you present MEFC in substitution of softwood fiber to produce this FMC? You will probably need extra energy and investment. How will stand the economical balance
I'm
versus
sorry, you're kind of
the
broke up.
Okay, can I repeat? David, you are listening?
I'm listening, but your question broke up on me. I'm sorry.
Okay, I said that to produce MEFC, you will probably need extra energy and investment. I would like to know how will stand the economical balance between between this investment and this extra energy that you use versus the substitution of softwood fiber. What is the payback? This is, I think, is one of the most important questions that you will have here, because economics in our days is very important.
Even though I think MFC is a wonderful opportunity, it isn't necessarily an opportunity for everyone. Each mill's situation can be highly variable. For example, there are some mills here in North America that may have hydroelectric power, or somebody may be selling power back to a grid that they could use that power for. The example that I gave here, the 600 kilowatt hours per ton, is one of the lower levels of MFC. And there are many people that can get by with that level of power input into their fiber. Some require more. It depends upon which customer and what they want to try to accomplish. What we generally do at Valmet is work with each individual customer and their pulp type to give them a very accurate understanding of what would be the capital cost and what might the payback be. I've seen paybacks as short as 6 months, and obviously there are many that are much longer than that. So it's kind of something that we work with the customers on and try to do the best for them in their specific infra situation.
Okay. I still have another question for you, but first I would like to ask one question to Marko. At your abstract, you mentioned that converting data can influence production optimization, and also the opposite. That means is something that I understood that is something that can go from the paper machine to the converting, influencing the converting parameters and how runs the process, and the opposite. In which case can be most effective is my question.
Yeah, okay, let's say that most of the case what we have done until now is that we have the liner machine, liner paper machine, and we will transfer the liner paper quality data for the corrugator machine. And in the corrugator machine, we are utilizing the data to adjust the parameters in the machine. And that way, many times the problem is that the moisture profile is not even, and just to selecting right rolls in the corrugator together, that will help much with the quality of the final box boxes what we are doing in the corrugator. So that's the simple example. And then when we have that enough good quality in the corrugator, then we can transfer that data back to the liner machine and adjust the process there to optimize that side.
Okay.
I think it's the most simple example.
Okay, then I will have another question for David. Okay, as you know, probably customers are always targeting very high strength values, and you show us some examples. And the question is, how far we can go using MEFC, keeping the softwood fiber? We go to the sky with properties.
Life of promises, right? No.
Yeah.
I think, I'm not sure. I know at certain times, and these are more what I would call pilot explorations, we've gotten as many as 30 and 40% strength enhancements by not necessarily taking something out. But that isn't without, everything in paper making has some level of consequence to it that you don't get anything in life for free. So you have to do a balance of characteristics on the sheet and things like that. But you can get a good strength boost by using MFC. But one of the things that we found that MFC does really, really well is internal bond and tensile. Those are two things that MFC does very well. And then if you choose to add MFC on the surface sheet, you can influence sheet properties that way in a very large way.
Okay. Then I go back to Marko to do another question. Okay. When you did your presentation, we showed that you have a lot of we can say IQ devices working together. They are working in a certain kind of network that after will allow you to do some control loops or to do the predictive model, or you use artificial intelligence behind.
Yes, so basically, when we are talking about this, if these all equipment what I shown in my presentation are Valmet devices, then of course they are in the same network, in the same system, and that way that makes the life a little bit easier, so that they are already in the same system, and then we can connect these to the same optimism and the predictions calculations. So that's the easiest way. But of course, even if they are not the Valmet devices, then of course still it's possible to connect these via link or interface to the same system and that way communicate together. But of course, communication between the equipment is needed. Yes.
Okay. Now I go to change now to several questions that I got from the people that is following our discussion here and our question session. And the first one that I got was for David, and it was at the beginning of your presentation. And the question is, it is possible to have a measurement online similar to FES5?
Yes. Valmet sells a unit basically called the MapQ that can do online. And then you have a centralized MapQ unit, and then you have different sampling points that you can install at given points. We fully expect for a full-size production line of, let's say 40 to 50 tons a day, you might have a centralized MapQ, and then you might have 2 to 3 sensors testing that periodically throughout the process. The FS5 is a benchtop unit and is a little bit more economical for people that are doing research and small pilot units.
Okay. Marko, the question that I have for you, I think we answered before, but I think you should reinforce it, is, are these equipment somehow integrated in the network?
Yeah, maybe I see the question, and I don't know what exactly that means, because of course, as I said earlier, that systems must, or equipment must communicate together. So some kind of connection there must be. But if this question is meaning that need to collect the data for the cloud, so that there must be some connection outside from the mill. That's not the target. So that possible, of course, and makes sometimes life easier. But of course, we can do also the on-premise solution, which means that the data is moving only inside of the mill and the machine, and not outside. So both are possible.
Okay. Now I have one more question for David. David, that is, when comparing the scenarios with and without MEFC incorporation, were you able to identify variations in dust formation? Did MEFC increase the dust formation on the paper machine?
On this particular scenario, running in our tissue thing at Karlstad, we ran very, very short period of time to try to accomplish this. This was just basically the first wave of evaluations at Karlstad, since they had never played with MFC before. The commercial application, in which we ran some long wells 3 and 4 times, there was no additional dusting that was observed during that period of time. But however, we do not have history on what it would be to run MFC for a month on a tissue machine. No.
Okay. I have another question for you, David. That is, what are the disadvantages when using MEFC? Economic, process, product? There are always disadvantages.
Oh, there's always disadvantages and advantages to everything, right? But,
that is true.
So be it. One of the things that I alluded to in the discussion or in my presentation was that you have to, especially in the tissue world, it depends on where you're making the tissue and where it's being distributed. As we know, and the tissue suppliers will know, in North America, softness is king. I mean, we have it's ridiculous how soft some of our bath tissue is in North America. So there is a balance. Obviously, MFC will compact a sheet a little bit, so you have to be careful, especially in tissue. If you get, as I said, if you get too crazy with the addition level of MFC, you are going to hurt softness, and you're probably going to influence bulk. So it's somewhat of a balance. I think for the most part, a sweet spot for many MFC users, be it tissue or others, is typically between 2 and 4%. Now, and the second point is, if you get, especially like on a liner board or fine paper machine, if you're adding a large amount of MFC, you will impact drainage. MFC loves to hold water. So you need a decent, or what I would call at least a retention system of this century that you can have some influence there. So that's something that you also have to balance. You just can't throw in 10 to 15% MFC and expect your machine to run the same. It will not.
Okay. I have now a question for Marko. That is, does the system provide online softness measurement for tissue?
Yes, that's let's say the short answer that yes, we have the online softness sensor to measure the online softness, but not only the softness, but also the creping properties like creping frequency and so on. So yes, we have that available.
Okay. Another question for David. As well known, C has an impact on softness, decrease for toilet paper. What about the wet strength for kitchen walls, for example, and the impact on absorption?
As I said, we at Karlstad, we basically ran a tissue run. The other case study that I gave, they did run one toweling run, and it was I guess you could call it a private label kind of commercial towel. And my understanding is that all of the and all the normal sheet specifications were met with MFC and some reduction of software.
Okay. I didn't receive more questions. If someone please wants to do more questions. Okay, maybe I will do another question to you, David, is how MEFC can interact with other chemical dry strain programs?
Well, I would say right now at this time we're still that's still probably something in exploration. MFC is not what you would or what most people would expect. It's not just some detrimental dumping of fines in the system. For example, there has been some people that have done, I would say, cursory research that MFC actually has been able to improve certain dye retention within a sheet. So it's not what I would call, and it doesn't act like, quote, a normal pulp compared to of what you might think.
Okay, and let me see if I will be able to do another question.
Our whole tissue program is very much in the infancy. So,
Marko, with all the devices that you are promoting in the paper industry, especially based on this quality platform, what is expected from Valmet regarding prediction and modeling?
Yeah.
I can top of it if you want the question that I received just now. For example, to modeling softness, which main variables must be chosen using your devices?
Yes. Okay. If you think about, for example, the tissue softness, as I said that we have also the online measurement available for that. So basically, the prediction or modeling is not needed because we have the device for that. But of course, when we are talking about the softness, everyone knows that it's not so simple with the softness. Even we have the online measurement to measure the softness. That's valid in the some grade, some parameters, but to improve the softness prediction, of course, it's one way to add the more parameters and do the modeling top of that, and then it's depending, of course, the little bit the machine and the stock what it will be used, fibers what will be used, but of course there is some basic parameters like chemicals and refinings and the fibers what are used. These are the basic parameters what will be used. But then normally we are doing this kind of data discovery, collect the data a couple of months from the mill and see that what is the best fit for the modeling, which parameters in that particular machine are important to predict the softness. For example, okay. Same with the strength, for example, for the tissue.
Mm-hmm. Now we have probably the most challenging question for Valmet, that is, what are the benefits Valmet can bring when thinking about digital transformation initiatives such as an autonomous mill? This is a huge challenge.
Yes, it is. It is definitely, yes. But let's say that we are way for that direction. So if we can predict the parameters which cannot be measured online, and if we can predict these with trustable way, and we can connect these to the optimization, of course that will close lots of these kind of control loops which are typically do by operator manually and visually only. So that's at least a good starting point to that direction.
Okay, is 1 minute that we have. I would like to thank you your excellent presentations and also your explanations to the questions that we did. And I would like to finish this session now because we are on the deadline. And I would like to ask to the attendees to join our next section of Tecnicelpa that will be present at Coimbra room, that will be presented by, it will be moderated by Nuno Borralho and will be dedicated to forest. Guys, thank you very much.
Thank you.
Thank you, David.